Okay, so now the next step is to find out, do some analysis and see how sensitive the cutoff point is in our prediction process. Okay. Is prediction process very sensitive to the cutoff value or what? Okay. So first let us set up formulas for accuracy and overall error rate, which is pretty straightforward. Accuracy would be, remember, accuracy is the numbers along the diagonal, okay, divided by that number. Okay. And overall error rate is just 1 minus accuracy, or you can do this also. Okay. Either way. Now we want to analyze what happens at various points of the cutoff probability. Okay. So let's assume that we want to start with a cutoff value of 0 and increment it at 5%. Okay. So previous value plus 0.05. And we will copy that all the way till 1. Okay. So we're going to use these as the possible cutoff values. Okay. And for each of those cutoff values, what is the accuracy and what is the error rate? So we have two columns of output, which is set up in the first row, and we're going to use data table, and I'm sure you're familiar with the data table. Okay, so highlight this range, and in the what if analysis you have data table, and here the input values or the cutoff value. These are the different cutoff values that you want to insert in here. And since the cutoff values are set up as a column, this is a column input cell, which is that. Okay. So now each of these cutoff values will be inserted there, and these two formulas will be computed in the remaining highlighted cells. Click OK, and now we have the accuracy and error rate probabilities. Now we want to do a scatter plot. Or even line plot would be okay. So either one line plot would be okay. Yeah, we'll do a line plot. Okay. If you do the scatter plot, then you have to, both of them would be y's, and the cutoff values will be the x's. So if you do a line plot, the cutoff values must be entered separately. So like that. You can do a line plot like this, and then you have to change the x range to that. And the series name for the first one is accuracy. The series name for the second column is overall error rate. Okay, so like that. So this will be accuracy and error rate by cutoff probability. Okay. And the axis titles, so this will be the cutoff probability. This is accuracy and error rate. Okay. Now when you examine this graph, of course error rate is going to be the opposite of accuracy, and you see about here, from here on, the accuracy rate is about the same. See, it starts off with 50% and quickly jumps up to 75, okay, and to more than 80%. And then it remains in that range all the way till here, and then it drops off. So for a range of cutoff probabilities, the accuracy rate remains stable. So the prediction that we're going to get from this data set is quite robust with respect to cutoff point. Even if our cutoff point is not very good, or we are not very precise in our cutoff points, our classifications are not going to be that different if we had a wrong cutoff point. Now again, I want to illustrate how to do this with a scatter plot also. So for scatter plot, same thing can be done. You start with 1y. Okay, so this will be select that one. Okay, and then you add the second one. So the name, the x values of these, and the y values are the overall error rate. Okay, and you have to adjust the first one too. The first one is accuracy, and the x range is same. So then you'd see that you get the same plot, and then you have to format it. Okay, so you can use either scatter plot or line plot. Both will give you the same graph.